Yeah, let's talk about the function calling for LLMs. So if you conventionally look at what LLMs do, they literally have the generate text or text completion task, while as technology and everything about the LLMs have changed, they have embedded the function calling into the LLMs, and this has actually constituted the fundamentals of AI agents. So what the AI agents do, they are given some queries from the user, and then they do some tasks, and those tasks are embedded through what tools or what functions they have available at their hand, right? So what they do, the LLMs, they recommend to do a particular task, given all the tools and all the functions that are provided through a structured output. And it also provides even the arguments that you can use in order to call those functions as well, or invoke those functions. But you have to remember that these LLMs cannot or will not be able to execute for the user. So what happens is there needs to be the execution process. So you're going to do the execution. Well, actually, user does that. So the user does the execution, and it goes back to the function calling. The results comes from those executions, and then it all gives to the LLM to provide the result. So the best use case of LLM function calling is in repetitive or iterative tasks. And one example of this is the shopping. So when you go shopping, you do a search, you find your item, and then you purchase. So it has different steps. You go for a shopping, and then you try to find the appropriate item with some filtering, with some search, and then you purchase. This can readily be done by an agent. And as of today, most of the AI labs like OpenAI, they already have embedded the shopping engine into their platform. So you can go on, let's say, chatgpt.com, and then you can search for something, and then you find your item, and then you can even tell OpenAI that, hey, I want to buy this, and then they're going to buy on your behalf. Here I wanted to talk about a little bit of the knowledge base progress for these LLMs. So essentially, when the LLM started, back in 2023, when ChatGPT 3.5 came out, models had a knowledge cutoff, and it was all based on data that was trained on, and most of the time they had some knowledge cutoff. And if you ask a question about something trending or something that is current, these models were not able to do a knowledge base. So they had a knowledge gap at the time, and so it was not possible to use that. As things progress, so the LLMs had the capability to interconnect with the retrieval augmented generation, or RAG systems, which has the underlying vector stored database. And basically what happens is you have a knowledge base or an information database, and what you can do is you can leverage using embedding models in order to transform your knowledge base into some vector variants of those knowledge. And these vectors can actually be retrieved by the LLMs. And so we were able to give some context from the rack system into the LLM. So the LLM's knowledge is enriched by that. But again, this rack system has some limitations. You can only serve the amount of data that you have. You don't have the ability to go beyond those data. So the tool calling came around, and tool calling for the LLMs provides the ability for the LLM to make actions, but again, not on behalf of the user, but suggesting to the user to do those tasks. But actually, when you go to chatgpt.com or ask something, or maybe Perplexity or any other of these AI frameworks or AI platforms, when you ask a question, you can see that there's a web search or any sort of search that is happening under the hood, and which is on their system. They already given the instructions for the model to go in and do a certain task. So these tool calling has really enhanced the ability of these models to take actions and to provide recommendations to take particular actions or proper actions. And finally, concept of the MCP server is, which is a model context protocol, is becoming more and more trending because we are now leveraging having servers to provide the access points or the access tools or anything that these models needs to be aware of, kind of giving the models the awareness of their environment or even the internet itself. And then the concept of the agent to agents or A to A becoming very, very important. And most of the things that we talk about agentic workflow or agents interconnect with another agents or provide some results are coming through the concept of the MCP server. Function calling is to enrich the model's knowledge base by giving tools and functions and add clear and concise instructions on how to use them. This is very important because models need to be aware of what the tools are, what the descriptions are, what arguments they need, and what type of scenarios or examples do they need to work on. So a typical process for function calling is, so from the developer side, you send a query. So for example, you already have given the LLM the instructions about getting weather information. This is a very simple example that you can see across all the documentation. So you have some information about the weather function and you give it to the model. The model analyzes the query and then provides some suggestion of what to use, the function and what arguments to use. It gives to the developer executes those functions and then gets the information. Everything that happens here needs to be returned to the model and the model eventually gives a final response. So on the OpenAI documentation, they're talking about different fields that needs to be provided when providing the functions. So these are the things that needs to be passed in order for the model to be aware of what it needs to work on. And here's an example for get weather function. You have a description. Again, this description could be very detailed and also with some examples of how to use it. And the parameters, what inputs are required for this function, and the other things. So Anthropic pretty much has the same data structure to provide function calling or enabling function calling for the LLMs, except that for the Anthropic, there might be a key naming convention that is different than OpenAI. So in OpenAI, we have the parameters, whereas here we have the input schema. That's the only thing that is different, but everything else remains the same. Gemini has pretty much the same sort of process. The application sends a prompt with the function definition, and then the model or Gemini decides what to respond. So the only difference is it has some answer for the first call, and it also gives some information about the function and the argument to be called. And then the users call those functions and then sends everything to the model, and then the model provides the final question. So just summarize, the steps that it takes for the function calling is you send the query with the tools to the LLM through the API. You can leverage using models like GPT 4.1, GPT 5, or recently the GPT 5.1 came out. There's the Gemini 3 that you can use, or you can use even the Anthropic models like the Sonnet 4.5 and so on and so forth. So you send all those information to these APIs, and then once you get the response from the LLM for the tools to be called, you then handle the executed functions, so invoke those functions with the relevant arguments, and then send all the results back to the LLM, and the LLM provides the summary for handling those output response. And so one thing that you need to note in order for you to save some API cost is a lot of times when it comes to understanding what tools to call, I would say maybe better to use some better models like GPT-5. Whereas when it comes to the final response, that you just need to generate a summary of the response. A lower tier model like 4.0 or even the mini versions of these good models would be enough to do the task for you, because it just doesn't have a complicated task. Whereas for identifying what tools to be called, these needs maybe to some extent, because that's might be a more complex task. So it's better for you to use a better model. And so yeah, this is very important, because this really, when you go into production scale, this really helps you, save so many of the inference costs. You might be asking, what are some popular applications of function calling? Well, there might be instance where you need to do data retrieval. So you might want to see, users asking about the details of the orders they had in the past 10 days. So that's something that you can consider. You can put a SQL query inside a function and then give it as an instruction for the model, and the model provides the necessary input for that based on user's input. You might want to do a running actions. You might want to get access to, search on the internet, or do a scraping on the internet, or find more information, or call an API, or anything else. So you can pretty much do any action on that side as well. Sometimes you need to call maybe third libraries. So maybe you're doing some complicated examples, maybe like you're running an optimization problem, or there's some, complicated tasks. And then, these models are really good at using those libraries, or even suggesting what libraries to use. Or maybe in the coding environment, or you doing a vibe coding, you might really end up using these abilities as well. And even sometimes you might want to use the function calling to handle multiple tasking capabilities. So let's say you want to do data transformation analysis, ETL, all through one call to the LLM. So you can just say, hey, I have these data and I want to do analytics on it, and you already have given the dashboard functions, the analytics, ETL, data transformation, because you know that your data source comes from a specific database, and so you have a specific business, so you can leverage using those function calls as well. There might be some questions around function callings and the LLM calls. Is there a way to handle function calling and tools in one call? So basically, can I ask the model to do some task for me, and it's just like one call without even me trying to go back and do the execution myself? Well, the answer is no, because that's the intent of being a secure API call, and without giving the API access to your system or to your computer to do the executions on your behalf, which is going to be very risky and put your security at risk. And this is way not something that you would consider for production, unless you do things on your own and then you have your system that does those tasks for you. Can I handle multiple function calls in one run? Absolutely. If you have a complicated task or something that requires multiple calls to multiple functions, then you're able to use some capabilities of maybe your CPUs, or maybe multi-threading or something like that, so you can have parallel calling of those functions. Also, these models have the ability to provide the instructions on how to do function calling in parallel. You can go to Gemini's documentation, and they have quite extensive of some examples of that as well. When should I use function calling versus embedding or LLM fine-tuning? Embeddings are best for the cases or scenarios when your data doesn't change that much. Whereas for LLM fine-tuning, you pretty much have a very solid foundation for your business, and it does not change maybe in the next 10 years. So it makes sense to do LLM fine-tuning. Whereas with function calling, it gives you the ability to be very flexible and adaptive to the changes in your data, to the changes in the environment, to the changes in the news or in internet or whatever. I would say you need to look into the foundation of how your environment is changing, or your business is changing. But the first choice that I would go with is the function calling, because it's very simple. It's very simple to implement. Whereas for embeddings, you need separate data structure, you need a database, you need a vector store, and that really accumulates the cost for you. Well, and also in terms of LLM fine tuning, it requires extensive amount of effort to put into building that data set, which is curated for processing and fine tuning. And yeah, so first option, function calling, and then go to the other options. How do I ensure the model calls the right tool? Well, this is a very important one. When you look at how you call the model or the LLM to use what tool, you might better off giving an extensive amount of prompt or system prompt, giving more awareness about the tool, as well as also giving it some examples, like few short examples of for what purposes do we commonly use this tool for. So for example, if you have a tool that retrieves the order details or the history of your orders, and then you can give some examples, say like this we call for orders on this category, we call this function, or this or this or that. So then your model is better aligned with how to use them. But what if the model returns malformed JSON? This barely happens. The models are very good at if given the instructions and also the arguments that they need to get and they need to pass. There might be a scenario where you might see a malformed JSON, and then if that happens, it actually happens on the LLM side, so you could barely see that it is happening from that side. Perhaps maybe you could have you could arrange exception for this to retry the model, or kind of give it back to the LLM to retry it, or giving the instructions on what happened that this malformed JSON was returned. You need to write clear and very detailed function names and be very specific. The sort of the practices that the software developers used to have was be clear on the namings. They have naming conventions, they have camel case, or they have the snake case, and things like that. So you need to be aware of how to be clear on the instructions for the functions, for the descriptions, for the instructions, for the parameters, arguments, etc. So usually they say like keep the number of function calls to be as low as possible, because if you have higher number of functions, then it really reduces the capacity of the model, because the model's context window is very minimal or limited. So you might end up having confusing model calls or tool calls, and this really is a suggestion to go less than 20 functions. Okay, now we're going to go into some examples of function calling. So I'm going to walk you through a very simple example. We're going to go through step by step, do a function calling, how we can build it, and how we can do a debugging in this. And then the second step, we're going to do a more complicated function calling example. And then I want to go into just not only using OpenAI API, but also I'm going to show you how to use the Gemini API as well. And then in a fourth step, I'm going to show you how to do a multi-function calling if, for example, a certain function is called multiple times, or the other way around. And I'm also having, I'm going to do this in a JavaScript as well as Python as well. So you have both frameworks in the same time. Let's get to the code. Okay, now we're going to go through some examples of using the LLMs for function calling. So I have this GitHub already. So what you can do, you can just go and then grab the code and then run as I walk you through the whole process of running everything. So it has all the instructions, the README file is here. So everything is there. I'll put a link to in the description to be able to grab the code as well. So what you need to do is grab the GitHub code, and then you just go into your IDE. So right now I'm using the VSCode, and then just do git clone, paste the URL, and then you should be able to get your environment. Because I want to walk you through step by step, so I'm going to start from the commits where I have the step 1. So if you want to look into what commits I have, I can see all the commits history of this repository. So I'm going to start from the step 1. So I'm going to copy the commit hash for this, git checkout to that commit. So as you can see, I have some JavaScript files, .env file, and I've also put the prompts here so that if you want to regenerate the same code that I have already done here, so you are able to reproduce the sort of the code that I have already done. I have set up an app service, so I'm using the Express from Node.js to run my app service, and I do call the model, and I just wanted to test how it's working, and I have some endpoints as well for this. And so for this specific application, I have the news endpoint. You have the query, and then you'll pass the user's input to the OpenAI. Right now I'm using the GPT for 4.1 and I have this function call. So I pass the functions and then I get a response and I go through the responses and then try to go through the function calls one by one and then run the function calls. Right now I only have one tool, which is the news. I'm leveraging using that. And then eventually I'm going to use the summary response with this model and then I ask the AI to generate the summary for that. And then once I get the summary, I return the JSON of that response. The first step is to set up your environment variables. So if you go to the .env example, you can see that there's the OpenAI key Apify token that I need. All right, so I've already set up my .env file. Now what I can do is I want to run my server, but because this is a Node.js, for Node.js applications, I need to initially run the npm install. But by the way, if you want to work and walk along with me with this development, you have to make sure that you have Node installed as well as the npm. So for Node, you need a version 22, and then for npm, you need a version 11.3. So I do an npm install. Now everything is set up, so I can just run the Node from the server. And as you can see right now, my server is running on port 3000. So for now, I just run this from terminal, and then I'll show you how to run it through a debug mode. So there are different ways that I can do a testing and call this endpoint. So one way is to do through curl, where you open the terminal and then you pass the relevant information and then the request body. I generate this test news.js. So I have this test news. I'm using this local host for now, but later on I will show you once I publish this into the cloud, and I'll show you how I'm able to connect to that and then call that endpoint. So just making sure that my server is running on port 3000, and then I run the test. So there are different ways that you can run the testing, either through the curl, or you can install the Postman, or you can literally have another file, like another JavaScript test file, in order to run that. So for example, here I ask a question, what are the latest news about AI? And it identifies the topic, so calls the model and then gets the response and then runs through the summary, and here are the results. It was pretty simple, just one call, getting the information that we need from the function and call the function and then execute that, get the results, and then put it into the LLM, and the LLM generates the summary. Now, in this particular case, you would like to do a debugging, right? And that's pretty much most of the things that I personally do when I'm developing or working with these models. To run it in a debug mode, what you need to do is you go to this run a debug tab on your VSCode, or if you're running on Cursor, and then there's an option called JavaScript debug terminal. So once you click that, right now you can see that this is labeled as the JavaScript debug terminal, and then anywhere in your code you can just put a breakpoint and then run that server. And as you can see, this is right now I'm in the debug mode and I'm running this JavaScript file line by line. For example, if I go to this and put the try line 57, so now I can see that my server is running through that debug terminal, and then now I just call the same test. There you go. And yeah, we're in a function where we're calling the news endpoint, passing over all the way here. So the first thing is we're gonna get a response from OpenAI to get the functions that we need. So I'm going to do a continue. It's going to take some time. Yes, there we go. We got a response back for the AI response. As you can see, it has the AI response, and I can basically see under the AI response what parameters I have, what are the methods, what are the attributes that I can use. So initially I wanted to look at how many tokens did I use, what's the token completions, and so on and so forth, to be able to get some cost estimate for that particular call. So in this case, and in order to view all the calls, what I can do is I can just put another breakpoint here and then look at the message here, just print message. Yeah, this message has one value. It has a role assistant, so it's just giving us instructions. So as you can see, it has this attribute function. So if I do message dot function call, it gives me exactly what functions need to be called, plus what arguments need to be passed, plus what value that argument should be. Okay. Now, if I go to my functions, so here's the tools that I passed over to the OpenAI. So OpenAI recognized the function name and also the topic and the language that it's supposed to be passed. Now, if I go to the functions, there I have the topic and the language, and it has properly identified what topic to pass and what language, which is very interesting. This part, which is a step 2, is where I take all the arguments from OpenAI or from the function call, run those corresponding functions. So I have some code. I've put some code here to run those functions, right? So I have parse those arguments and get them, and then once I have the results, then I call the function. And then once I get all the information, then I'll pass it again to the OpenAI for me to generate the results. And if I put another breakpoint here and I do the run, there you go. And so in the generate summary, the total tokens was about 660 tokens being consumed, and the approximate cost was about very, very minimal. I don't know, it's 0.5, 0.4, or almost 0.5%, which is really small. Okay, yeah. So, and then eventually we're gonna return a result to where it has been passed or the request has been called, and then you get results. Yeah. So that's how you can use debugging in terminals. So now we're going to the step 2, which is we want to have multiple functions or multiple things and be able to call the OpenAI to make a decision on how to be able to use these function callings and things like that. Okay, so in order to do that, so I'm back to the main, and now I need to go to the step 2 commit. So I copy the commit hash, and then I do git checkout the hash. So there I am, and I'm here right now. So again, if I look under the functions, there are a few things that I've added here. So the get latest news is from the previous step. And now one thing I have added is the get Google Places. So basically what I'm doing here, I'm using a service from the Apify. So if you're not familiar with Apify, it's a platform where you're able to access some of the challenging API requests that might be hard to get, but through Apify you're able to access many API services, including calling the Google Places. And in order for you to set up the Apify, you need to go and sign up on the Apify website and be able to generate an Apify token. And I have a link to the instructions on how you are able to get the Apify token as well. So yeah, this function has some inputs and some results. It directly goes and calls the Apify API and gets a response back. I've also added an instruction here on how to run. So this documentation helps you to be able to run the server as well as get examples. So here I have some curl example. In the previous step, I showed you how to call the server from a JavaScript file. Now here you can call from curl or from terminal. So yeah, I'm just gonna run the server one more time, and I open another terminal, and I go to the how to run, and I take one of these examples, copy and paste it here. As you can see, it's gonna call the tool that has been used was the get latest news, get some results, and then generates the summary here, and then also the amount of cost that the tokens that are being used, the cost associated with that. In step 3, we're going to call the Gemini API. So we did with the OpenAI in the previous step. I have this commit here, but I made some changes. So I have a branch for this. So if you look at here, I have a step 3a branch. So I can do git checkout. I have the server, I have the tools, and I have the functions. On the server, I'm importing the registration for all the tools. I'm also putting in the importing the functions from my function JavaScript file. So I have 4 functions here. So I've added 2 simple functions like get time and convert units. These are some static functions. They don't call any API, so they're not that complicated. So it's good. I've also added like a list tools for Gemini. So if you go to the tools, I have several functions that I'm using. So this register tool adds the tools to the tool registry, which is a hash map, and I have a dispatcher here to sort of which function is being called and things like that. I think the nice thing about this function is its complexity is 01. Now going back to my server, I have my Express, and then I register the tools. So I have the latest news, the Google Places, the convert units, and then I get time. So here I have all the registrations. I have my 2 API clients for OpenAI and then the Gemini. Here I have some function helpers to estimate the amount of cost in terms of the token and the dollars for every call that I do to these models. And then I have the endpoints. So the post query is by default calling the OpenAI. And then I have another endpoint, which is query-Gemini. It's just for calling the Gemini endpoint. For OpenAI, I'm using the 4.0 to understand the functions that I need to call. I'm using the 4.0 mini to summarize the results. For Gemini, I'm using the Gemini 2.5 Flash. Yeah, so what I have one function that does return this JSON. So the title, the source, the URL, and then the time that it was published for the articles. And then I have this other function, get Google Places. So its input is CD, query, the language, and the maximum result. So right now it is 50, which is very high. So I can lower it down maybe to 10. But for now, I just put it as a default. And then it takes the Apify token. And just remember that the Apify token, when you use it, you have a certain amount of token to use. And so after that, you need to pay for the version, for the premium version. Yeah, it has some inputs that you need to put, and yeah, you need to go to the documentation, or if you want to learn more about the Apify Google Maps, so you can search for that. But for now, we just need to pass this input and get some information about the places that we can find about a specific query. We then eventually return this JSON. We get the title, the rating of the place, review counts, sort of the address, the phone, website, whatever is on the Google map about that. Then we have the convert unit. As I mentioned, this is very simple. It just converts, I think, Fahrenheit to centigrade or vice versa. And then we have the current time. Let's run our server. So in order to run it, we call the node. Right now it's running on port 3000. And as you can see, everything is imported and everything is running successfully. Open another terminal, and then I can run the different queries. So because in the previous example, we ran with OpenAI. Now we're gonna run with the Gemini. So let's just put this curl. And so all these requests are actually in the how to run markdown file. So if you want to rerun these examples, you just can go through here and then copy paste the same way that I'm doing right now. Calling the service, the backend service, and the post method for query Gemini, and I'm asking what time is it right now. And what I'm expecting is the Gemini call should return a function call for that exact function I have. As you can see here, the Gemini 2 calls call this get time, and then it returns the current time in an ISO format. So now if I do the same and then just call the query, which is the OpenAI, let's see what it returns. I call the same, this time to the OpenAI, and I get pretty much the same response. And as you can see, it took roughly around 300 tokens, and this is the cost. Okay, so that's good. Now we're going to go a little bit in depth. I have another example where I want to look for locations, for example, in a place. So here I'm asking, find me top-rated Italian restaurants in Chicago, right? So I paste it here right now, asking the query to the Gemini model. Yeah, usually it takes time. So yeah, because it's calling the get Google Places, and that is associated with the Apify token, and that perhaps is a very busy endpoint, and so it might gonna take some time, but eventually comes with a response. Here are some top-rated restaurants in Chicago, and then here are the all the places to go, their address, their telephone number, and everything else. And here's the server. So we can actually ask the same question with the OpenAI and then see the differences. The response from OpenAI just came back and called the same function. But to my understanding, it sounds like the response from OpenAI is a little bit verbose, which means that it has more information about the places. Contextually, the things that has been returned from OpenAI is to some extent better, but it's just the amount of verbosity that I can see here. So it's not like clear which one is better unless it comes to the business itself. So just to give you an idea of the usage that it had for these two calls. So here is total API requests I had for my Gemini. So as you can see, I did 4 API requests, and the amount of tokens that I've used so far for this Gemini 2.5 Flash is around 77k tokens. Now for OpenAI, I have less than even 1 cent of consumption. Around 0.2 cents was for the GPT-4o. So this one was for function calling. So that's for today, as you can see. And then for the summary generation, I have the GPT-4o mini. So for other days, I have consumed other models as well. Yeah, it's not that significant. It's just maybe 1 or 2 calls, or at most 4 calls. But when it comes to production, definitely this pay-as-you-go model will significantly consume a lot of tokens and a lot of APIs. Okay, now in step 4, we're going to see some complicated examples of these function calling. So I'm going to show you and walk you through when we ask complex questions, and which is multiple calls to one function, or perhaps there might be the need for multiple tools to be used for a certain query. So we're going to get started in that. Right now on the main branch, in order to walk you through a step-by-step, I need to check out to the commit itself, the commit hash. So now I'm on this step 4. Nothing changes from the previous step, except that we're going to run some more convoluted examples. So we're going to run the server. So make sure you have your Gemini, OpenAI, Apify, and Newski as well. For this time, I'm going to use this function, query Gemini, where I'm asking the current time, the conversion for temperature, find me places in New York, as well as telling me the news about the climate change. So again, this is like 4 things that we expect that the model would be able to use and then return back. So let's run this again, because it needs multiple calls and multiple information, so it might gonna take some time. Okay, so I had to actually check out to that branch that I had, because I've made some changes to the tools in the and then the implementation for the server, because the Google Gemini API call has changed their documentation, so I had to make some changes there. But as you can see here, as in a result, based on this question, or based on this user prompt, it was able to call all 4 functions successfully and then get all the information it needs. Now, if I do the same and call the OpenAI, let's see what response do we get. This may gonna take some time. The OpenAI returned again with the same 2 calls. The OpenAI was very verbose, so it 71,000, more than 71,000 tokens to accomplish this call. And as you can see, these are, just some examples that we do, and then maybe the real world use case might be way more convoluted and more complex. This looks really good. What I really want you to notice here is for even a simple call to get information from an endpoint or an API, it really requires significant amount of tokens to be consumed, and also the cost as well, to even do a call for, let's say, Google Places. So now this time, what I want to do is I want to actually run my server in debug mode, so that I want to know exactly how the function calling is working and how different tools are being called. I need to go to the run and debug, and then there's a JavaScript debug terminal. So I click on that. It has the debug icon here with the JavaScript debug terminal, so I can run the Node server. And I believe this is the similar approach for when you are using the cursor as well. So now I want to put a breakpoint in the Gemini API, put it here on the line 200. I'm calling the query Gemini. This time I'm asking a little bit more realistic question. I'm doing research on tech hubs. Tell me the latest news about AI and blockchain. Also find me co-working spaces in San Francisco and Texas. Let's see what it does. I run this curl, or this request. Again, this is an HTTP request with a post method, and this is the endpoint, and this is the header, and this is the body of the message, and that's it. So now as you can see, the breaking point is here, so I'm calling this query, and this is a query, this is the string of that query. So what I do is I go step by step, and then pass the tools to the method to be called for Gemini. I put the breakpoint here and then run it. So right now is that first stage of calling the API. So in order to check the function calls, so I can call the function, as you can see, it has 4 calls. So if I open it, this function call is actually calling 2 times the get latest news, and then 2 times the get Google Places. Interesting. So what was our query? Our query was, number 1, tell me the latest news about AI, and tell me the latest news about blockchain. So it has 2 different topics about the news. And also find me co-working spaces in San Francisco and in Austin, Texas. So it has, again, 2 separate requests, and the model was able to identify these in a separate call. And for example, the first function call is calling this get latest news, and this is a topic. The second one, the topic is blockchain. The third one, it's passing the city and the query. Interesting. And getting the Google Places. And finally, the last one, the city, which is the Austin. So this might be a little bit tricky because it mentions about the Austin, Texas. So Texas is actually not it's a state, so it's not a city. So this might return some error, but we'll have to see. I mean, it all depends on the endpoints, or the Apify token. Sorry, Apify endpoints that we are calling, and we'll have to see. Okay, so what I'm gonna do, I'm gonna let it run. So what I'll do, I'll put the breakpoint in the 246. Okay, and then I hit continue. So as you can see, it calls the get latest and get latest news with these things, and then also get Google Places. So these three is called, so I believe these two were quick, and as you can see, this one also was completed, and now this one. So kind of like going sequentially through that code that I have here. So in this code, what I do is I have an async process here to dispatch those function calls. And there you go. And this is done. What I do is I want to look at the function response parts. Again, I have 4, which is interesting. So I have the first response for the get latest news, and the response I have 5 different references. All the references are here, and this is all coming, live. So today is December 2025, and I have information about news about December 8th, and so on and so forth. So it's very interesting. This is some of the capabilities that I really am passionate about, the function calling and tools, and just thinking of how much time we can save, and with the effort that we can put to build these I would call it agentic platform or agentic frameworks, and get the AI go and do the task for us. Finally, if I run this, you get the final response. And this is the results that I get. This is the JSON result. So the first is the tool calls have been called, so the list of all the tools, and then finally the summary. What I can say is this dispatch is an IO bound, and so what happens is it's gonna wait until this one is finished, and then return the response to a command to the function response parts. So that really kind of consumes a little bit of your time here. So you might want to, once you go into production, you definitely need to have a more efficient way to define this function. But I guess for now, as I'm just doing this tutorial, this should be good and fine. So far, I have done all these works and everything within a JavaScript and using the Node.js. I've established the backend server using the Express. We've gone through some examples of that, running it within the server, calling the endpoints on the server, calling the APIs through that server. Now, there might be some of my audiences who are really working with the Python code. So what I'm going to do is I'm going to walk you through some examples within the Python, and also how the Python code could be different. So for that, I have to rebase this branch with the latest main branch. So what I do is I take all the things from the main, and as you can see, I get the merge conflict. I need to rebase everything on that. Git pull origin main again, and as you can see, there's some conflicts that happening in this file. So I have resolved all those merge conflict. I can commit those changes, and then I would be good to go. So I have the functions, the server, and a tool. So for server, I'm using the fast API. I pretty much have sort of the same imports for the code that I had for the JavaScript. I have the register tool, the dispatch, the lists for OpenAI and Gemini, and also the actual functions as well. Again, it's very similar. So if you have skipped the JavaScript part, so what we are doing here, we're trying to establish a server that runs API calls for Gemini and OpenAI. So in order to run the Python code, you actually need to have a virtual environment. Right now, run the virtual environment by creating one. So in the visual environment, we're going to install all those libraries and then requirements. So now that we have all the packages installed, so we can run the server running on the port 3000 and on a local host. So here is one of those questions. As you can see, similarly, it's calling the get time, the get Google Places, and then again, another get Google Places. So the question that I ask is, I'm visiting Europe next month. What is the current time on the server for timestamp purposes? And also find me boutique hotels in Paris and Rome. And what are the latest travel news and restrictions for Europe? which is really cool. So I get all the information, and then there you go. Everything is done, and then I call the Gemini query Gemini, and I get a response, the results, and here it is. It's very verbose, called all the tools that it needs, and also the response as well. So very cool. So I open the server.py, and there are different ways that I can run this in debug mode, but the simplest way is on your main application where your server is running, or where you have this app where it has the fast API. You might need to add this extension at the end of your code to basically run this file from the terminal. We're going to run this in the debug environment. So here I have the Python debugger to debug the Python file, so I can run this from here. And as you can see, it's running from my environment variable, which is this one. And then there we go. It's running inside the debug mode. I'm going to look for the post method for query Gemini, and I put a breaking point at the line 218. And then if I go and then rerun the same question that I asked, or the same query, and boom, there I have the breaking point, and right now I can see the query, right? And then very similar to the JavaScript code, it get all the tools for the Gemini, it instantiate and then kind of like structure the configuration for that, and then pass it over. If I put the 238, or perhaps maybe going down to the 246, and then run this, right now I get function calls. And then if I look at the length of the function calls, it's 4. So it has 4 calls for the function. So it has get time, get Google Places, again, get Google Places, and then get the latest news. So get time doesn't have any input, so it's empty, or there's nothing here. For get Google Places, it needs to pass the query, the city. The same thing for get Google Places for the other question about the city, the query, the maximum results here. For the get latest news, it's about the travel news and restrictions. So I would argue that this has done some good job of understanding the user's input. But one thing I notice about a Google Gemini is it is right to the point that it does not try to infer from the user's context. So the query that I asked was, I'm visiting Europe, so the things that I would like to look for is the travel news and restrictions in Europe. Whereas this time, now, if we look at the results that comes from this news, and this would be maybe worldwide, or it would not be tailored for the Europe or the travel restrictions in Europe. So that might be a little bit of confusion. And we're gonna like do the same process with OpenAI in a few moments as well. I'm going to clear all the breakpoints, and then I look for where I have the query. As you can see here, this query is calling the OpenAI with its tools. So I'm going to put tool calls here. I'm going to put the breakpoint on line 163, and then I call this function. So here's the tools that have been called, and there we go. So I'm going to take a look at the calls and look at the length of that. So this time we have 5. So in the previous call, we had Gemini for 4 calls. For OpenAI, it comes as 5. So let's see why. So the first one is actually calling the get time, which is good. And then the second one is similar to the previous call. So Paris, and then so it calls the function for the Google Places, and then the same thing here. Now, the fourth one and the fifth one, it is way much better than what we got from the Gemini. So if you take a look, it's calling the European travel restrictions. So it's calling that function to get European travel restrictions, as well as latest news on the travel. Interesting. So while I'm working on different endpoints and different APIs, I noticed that OpenAI is giving a more reasonable response and results back. But in fact, this might not be true when you are, viewing this maybe in a year from now. Things are changing. The models are getting way much better. So I might gonna do another update on this video in the future where I'm gonna run, let's say, I don't know, maybe Gemini 4 or OpenAI GPT-6 comes out, so I can literally use those and then see the results that are coming back. But for now, I think using just the GPT-4o here, where I have access to the GPT-5, so I can literally kind of change it to GPT-5 and then see what the results are coming back. But even with GPT-4o, I get a very nice response, and it's very, tailored to the question that I ask. Whereas in the Gemini, there might be something that could have been done or could have improved and got better. In this section, what I want to do and focus on is the Dockers. So what are Dockers? Dockers are a sort of a layer that comes on top of the infrastructure layer. We have our hardware, CPU, RAM, and everything. So we have that infrastructure. And then on top of that, we have the operating system. So for example, Windows or Mac or Linux. Mostly we leverage using Linux OS for production, but we have examples or instances of using Windows. But anyways, and Docker is actually comes on top of our infrastructure as well as the platform. There's a concept around the PaaS and the IaaS and the SaaS. So software as a service is all, or SaaS are all the things that are on top of, let's say, an operating system. And so the user only deals with those. So that's called SaaS. It kind of acts as an intermediate layer between the software or the application and the platform to be able to help us analyze and identify and look into the application itself when it goes into, let's say, we want to deploy it into a server or a service. Because the things that they run on our services or in the Docker is to 95 to 99% is similar to what it's going to run on a service. Right now, most of the clouds, they are able to handle the Docker. So it's very easy for us to deploy a Docker image into a cloud. So there are a couple of definitions about Docker. So we have the containers, we have the images, and then we have the Docker engine, or in other words, Docker daemon. So what are the containers? Containers is basically the core concept of Docker. It is a lightweight, standalone, executable package that includes everything needed to run a piece of software. So this includes all the application code. So I'm going to walk you through two examples here where I'm running an application, whether it's a JavaScript or it's a Python, and I can show you exactly how we can run these two inside a Docker, and we just leverage using the compiler, only the compiler, to run within that container on our operating system, and it's a separate thing. And with Docker, the concept of distributed systems or subsystems just emerging now. So that's how it started. So we're going to have our application code or runtime, the system tools, libraries, settings, configurations, environment variables, set points, secrets, everything to be run inside a Docker. So this ensures that an application runs consistently across different environments. This is the part that I mentioned about. Once we are confident that our software is running within a container or within a Docker, then with a high certainty, we're sure that this will run on another environment. So yeah. And what are the images? So the Docker images are read-only templates that contain the instructions for creating a Docker container. They are built from a Docker file, which is a text file defining the steps to assemble an image. I'll show you how to write a Docker file and how to create a Docker image. And once you create a Docker image, you are able to mount the Docker image into the container. And your container is basically running on your laptops or your local. And once you're confident that your image is successfully running within a container, you are able to push it into the cloud and then run it on a cloud server. And we're going to have that discussion later on as well. And so the third thing that I want to talk about is the Docker engine. So the Docker engine is the runtime environment that allows you to build and run Docker images and containers. So it is basically a server or a daemon, and it has some REST API capabilities, and it also has some CLI feature as well. So basically what happens is you activate or you start your daemon or Docker daemon. So in Windows, when you run the Docker desktop, you already have access to it. In Linux and in Mac, you need to run the Docker daemon. So either you run it from your terminal or you run it from the application itself. And if you're running through Linux, usually it is run on the startup, but sometimes you actually need to run it. So there are some CLI instructions on how to run a Docker daemon in Linux. And I think if you search for Docker D, now we're going to create a Docker image based on the application that we built. And we're going to run that application on the same port, but this time inside a Docker container on our local machine. And in the next steps after that, we're going to push it into the Google Cloud. This time what I do is I check out the step 6 branch. Okay, so we want to do the Docker build. And if you go under the how to run, you can see all the instructions in order to build, run, and expose a Docker image and be able to run it. So I set up a working directory in that environment. So imagine that this is a VM and I'm starting to build my directory in that. So I have this app, and then what I do, I copy everything and put it into that app. So I want to like mention what type of instructions I need to put here and copy all the JavaScript files and then expose it to the Poet 3000 and then be able to run it. Okay, so right now CMD node server.js is very similar to running node server.js from the terminal. You just have to make sure that your Docker is available. So what I do first is I check that I have the latest version of the Docker. So at the time that I'm recording this video, it is 28.3.2. You can actually upgrade your Docker version as well. If I run this, it says that the Docker is not available, so I need to go in and run it. I can just run the Docker desktop from the Mac. Okay, so now I want to build the Docker image, so I already have the Docker file, right? And in the directory that I'm in right now, which is the main root, if I run this Docker build and I tag the name of that Docker image, and so for example here I said LLM dash function calling, and then I give it an image tag, and then in the current directory. So if I run this, as you can see, I already have some cached of this directory, so it's going to build on top of that. And now if you have the Docker or the containers image, you can see that you already have the LLM function calling, which is one of the which is the Docker image that I built. Now, if I wanted to run this, so what I can do in order to run it In the how to run Markdown file, I've already added all the instructions. So you just need to run a Docker run and then expose the port 3000, and you want to enable having the environment available. So you need to pass the .env path as well. So the name of the function is this, and it is version 0.1. Okay, so under the container, we have this LLM function calling that is running, so it's on port 3000. Okay, now if I open a new terminal, I just go and then run the queries before that I had. So for example, if I run this query, right, and I hit enter, and as you can see, it's actually calling from the container. So it's inside the container and it's exposed to port 3000, and I'm able to communicate with that through my application. And for example, here I ask a question, passing the query Gemini, right? Asking this endpoint, tell me about the latest breakthroughs in quantum computing, and I see the response and results coming back, the function that is being called, and a summary, which is really good. Or if I want to check if the Apify, the Google Places is called, I can pass this one, where I'm asking about to find top-rated Italian restaurants in Chicago. Again, the same endpoint to Gemini, and then as you can see, it's calling that. Gemini call is calling the get Google Places, and because sometimes it takes time for the response to come back, and there we go. Here we have the results. Okay, so now everything is working, and now, as I mentioned, this Docker file is what it's doing. It's running inside a container, and it is just a Node.js compiler or interpreter, and it's just running in that contain package. Okay, so we have done this for JavaScript. Now let's see how the process is for the Python. So inside the Python folder, so I already had the server.py, the tools.py, and the function.py. Similarly, what I do is I create two files. One is called Docker file, and then the other one is Docker ignore. So the purpose of Docker ignore is there are files or folders that are generated, for example, through my environment variables or libraries or packages and things like that. So I don't want them to be inside a container, because the container, the Docker image, because the Docker image needs to have only the essential files in order to run that. And because when we build a Docker image, all those dependencies are already embedded into that. So um, things like the .venv or the .env itself, or .get and things like that, they are necessarily not required for the application. Or inside of the Docker image, I don't need any Markdown file or any license or any README file or anything. And there are some cache files that are auto-generated by the compiler itself, so I don't want to push them into my my Docker. Or things like a Jupyter notebooks. These are kind of like the drafts. So they're not things that are supposed to be in production. So in the future, if you're running things inside a Jupyter notebook, just make sure that you put them in a Docker ignore so that they don't appear inside your Docker image, and that's for the fact that you want this Docker image to be as clean as possible. The Docker file inside the Python, it has the similar pattern and similar instructions, except that this is going to be tailored for the Python framework. So if I run the Docker build, now this time I'm using the Python LLM Function Calling, and then I put in a version 0.1, and then now this time I go to the Python directory or the Python folder, and then I hit enter, and as you can see, it's doing the same process from the server.py, the tools.py, so everything is put, and because I have already run this, so it has been cached into my Docker daemon, so it's not running things from scratch, and it's already there, so it's running out. So I'm running a Docker run on the port 8000, and I'm exposing the environment variables, the .env, and the name of the image that I created is called Python LLM Function Calling, and then the version is 0.1. Now, if I run that, as you can see, this is a Unicorn or the Fast API server that is running on port 8000. I already have the port 3000 running, and if I go and check on my containers, I can see that both the Python and the JavaScript services are running, or Node.js services are running on different ports. Now, if I open a new terminal and I take one of the examples, like this one, and instead of port 3000, I change it to port 8000. Okay, if I hit run, I go on port 3000. As you can see, the endpoint is called, it's activated. Now, the Gemini recognizes the tool calls. It's just going to call each tool, right, and then execute them, and then get a response back. And there we go. So the question I asked was, what is the current server time? And convert 30 Celsius to Fahrenheit. Find me pizza places in New York and tell me the latest news about climate change. It gives me the list of tool calls, and then I call them. So through the code inside the container, it calls these functions, get the results, and then call the OpenAI, or in this case, Gemini, and then get a summary and then come back with the results. That's pretty simple, isn't it? That's how I was able to successfully containerize the application. So I want to set up the Google Cloud Platform. Even if you have a Google account, so you can sign up for a Google Cloud Platform. It is free. There's nothing that you need to pay. But in order for you to be able to deploy an application on the cloud, you need to set up your billing information, right? So because without your billing information, you're not able to deploy your Docker images into the cloud. You are not able to create a cloud run and everything else. So the rest of this tutorial is dependent on that you set up your Google account properly. Once you set up your Google Cloud profile, and then you create a GCP project, and then you set up your billing information, then you need to create an artifact registry to be able to store Docker images, and then you need to create a Cloud Run instance under your project to host web applications or web services. This last step is optional, because if you're going to expose your application to the cloud or to the public, you want to make sure that all your secret keys, like the OpenAI API key or Apify token and everything else, they are all security stored inside a secret manager, and only at the system level, you only give access for the Cloud Run to read from those secret or keys. It is a very important notice, because everything that is exposed to the public or internet, there's a chance that there might be some malware or bad actors who would try to infiltrate expose or steal your keys. So we have already developed our application. So this one is done. We have already set up the Docker. We're going to go and then push our Docker into the artifact in, registry on the Google Cloud. And once you do that, then the deployment is pretty straightforward to the Cloud Run. And then you can also use the Circuit Manager as well. So let's get started. Okay, so let's go ahead and create a profile on Google Cloud Platform. So what you need to do is you go to your Google account and search for console.cloud.google. So you click on that. So when you go to your Google Cloud console, you should be able to see something like this if this is your first time running your Google Cloud. Once you start using and billing your account, you should be able to get a $300 free credit that's going to expire in 90 days. So now what you can do is you can just go ahead and create a new project. So you call it LLM Function Calling. So once I create the project, so there are already some options here. So there's a deploy an application. So if you click on that, and then you can see there are a couple of options to deploy an application into a Cloud Run, either to connect directly to your GitHub or deploy through the container. And because we're using the container, so we go to container, and as you can see, it asks us to enable the billing information. So you go to your billing and then start to link a billing. So you need to create a billing account. As you can see here, there are 2 steps, very simple. You just need to put your information, and so once you accomplish this, then you'll start to get $300 free credit, so you can use that. In my other account, I have already set up the billing information and everything, so I can just go ahead and deploy an application and then deploy through the container. Things that you need to enable. For example, you need to enable the API, you need to enable everything else. But for now, everything is working good. So in order to set up everything and be able to push your local Docker images into the cloud, you need to make sure that you have the gcloud CLI available. And in order for that, you need to go in and install that on your CLI. So whether you're on Windows or Mac or Linux, the installations might be different. I have already set up the gcloud, so if I do gcloud-v, I would be able to get the versioning of that here. So you basically need to install the gcloud SDK. For this step, I'm going to check out step 7 branch, and I've already added the instructions, what you need to do. So you need to set up the prerequisites, as I mentioned, the gcloud SDK, the step-by-step authentication, setting up the project, and enabling the artifact registry API, configuring your Docker for GCP authentication. On the how to run, I've also put the instructions, what you need to do. So I'm going to go step by step. You need to do gcloud auth login, basically. And then right now, once you see this authentication, then you're good. The other thing is you need to check what applications or what projects you have. So if I do projects list, I can get a list of all the projects that I'm working on. So for now, I need to set up a project for this specific. So I need a project for this specific function, LLM function. So what I do, I don't have any projects for that. So what I would do, go ahead and then create a project. So I call it function calling for LLMs. So here it says the project ID. So what I would suggest you to do is go ahead and then change that ID as well. So function calling LLMs, and then create that. So your function calling LLMs is created, as you can see here. If I do gcloud project list, now I can see that I have this function calling LLMs as well. So what I do, I'm going to go ahead and then set up as my default project. I want to enable the service. So there are 2 options that you can enable the artifact registry API. Either go directly into under that project, and as you can see here, it has not been enabled. So you can enable from the Google console, or you can do it from the terminals. I have already put the instructions on how to do it. So it's going to enable the service for this endpoint has been successfully. So if I go in and do a refresh here, you can see it's now enabled. So if I go to my artifact registry, I don't see anything here. It's an empty repository. So what I do, registry.io. So I need to enable that and configure that on the end. So for this specific case, I have this LLM function calling that I have previously built. I need to run the Docker tag. Now I have LLM function calling and it has the version 0.1, and I want to put another tag and call it function calling LLMs. So once I do that, and then I do a refresh here, there you go, I see another one just created. So this is the name of that. So if I do another refresh, as you can see, it has a function calling LLMs and the name of that Docker, and then this is the image. Okay, so now it's just I need to push that to the registry. So I do Docker push to the Google Cloud. And as you can see, it is very similar to when you build a Docker image. It has a bunch of clusters that they need to push. So it might get some time. Okay, so you go ahead to your Google Cloud Console and then do a refresh. And as you can see, you already have the repository for the gcr.io, and then you have your function calling LLMs. So now that I have set up Docker image, I need to go to the Cloud Run and then push this Docker image into a Cloud Run. So I just go ahead in Cloud and then do a deploy container. I can select from my existing ones. So I have this GCR function calling, this one, and then this image. I select that. So it says you need to enable the Cloud Run admin API. So we're gonna go ahead and then enable that. So it asked me for a location to deploy this container. So I'm looking for the Northeast Toronto, and then I'll try to have the allow public access for now. I don't need to have any sort of authentication in place, which I can talk about later. But for now, public access is good. I run this, but currently I'm getting an error, and it's talking about this particular image does not support the AMD 64 Linux. I have seen this issue before as well. So the solution to run over this, we need to add the platform as well. So the platform is going to be the Linux AMD 64. So for now, just to make sure that it doesn't, we clearly see everything. So I'm going to do, so it has to be Docker build platform Linux / AMD 64. The rest is okay. I'm gonna go ahead and then click on that, and then as you can see, it's gonna recreate a Docker image, and it's gonna go through the process. And as you can see, everything is complete. So if I do a refresh here, I have this version 0.2. So what I do is I'm gonna go ahead and then run the tagging, do for the 0.2 tag as well. And then now I'm gonna go ahead and then push the 0.2. So now I've successfully pushed the new image. What I do now, I go ahead inside the Google console, and then I do the edit and deploy new version. So right now there's the container image URL. So I'm going to select on that, and then I go to and click on the newer version here. This is version 0.2, and then I select, and then I deploy. So this time I don't see that error anymore, but I get another error, and that's complaining about the port 8080 environment, which is again can be solved. So you need to go in and do the deployment, and then there's a port here inside your Docker. You have exposed port 3000, where it says here on the container port we put port 8000. 8080, so I'm going to change that, and then I do a redeploy. I'm running the deployment, but it sounds like without the environment variables, the deployment would fail. So what I need to do is go into the edit and deploy, and then add all those variables and secrets. Okay, so now I have added all the environment variables as values, and now as you can see that the updating service has been completed and the creation was successful. So now all the routes to this specific URL is complete. We were able to deploy the app service into the Google Cloud Run. One thing that you need to know is if you have put anything inside the environment variables and you're directly putting your secrets or keys in the environment variables, then the chances are your environment variables are already exposed to publicly accessible. So there might be a chance that someone can basically access your keys. The best practice is store these secrets inside a secret manager on your Google Cloud. So I'm going to go ahead and then check out the branch for this. So we have the branch step 8. In this example, I talk about why you need to secure your setup with a secret manager and how to use them. First thing you need to do is to enable the secret manager API, create every secret. And it also depends on whether you running it on your personal account or you're using or leveraging using it within an enterprise account, because in an enterprise account, you might not have the owner access or the owner admin privilege. So you might need to ask your admin or the cloud consultation to be able to provide the access that you need. Once you have all the secrets on the secret manager, then you need to redeploy the cloud run. And once you redeploy the cloud run, you need to set all the secrets to the latest version of the secret that you have set up and deployed to the Google Cloud. Okay, so previously I have already made the changes. Now in the latest version of my deployment, I was able to update all the environment variables and use the secret manager. So if I go to the variables and secrets, right now I have set up all the secrets that I want to set up. I can even create new secrets and add them here. And once I do that, then I can deploy. It's going to take a few seconds. I've added a health check to make sure that the server is running and everything is working. I can go and then do all the tests that I did for all the local runs that I did for the services. So I have added a folder called tests. So if you do node tests test Gemini news. So let's take a look at what test Gemini news is. Gets its base URL from the .environment. Inside the .environment, you can set either your local host or the base URL that app service is running on the cloud. So you need to set your base URL to the value that you need. So right now I can just copy from the app service and then put it here, copy the same value into your actual .env. So right now I just put this in the .env example. Just run this. I'm getting the same response. To verify that this is actually working seamlessly with the local host as well, I'm going to run the server on my local host. So right now it says the base URL is set to this, change the .env to the local host. So if I change it to the localhost 3000, so I'm pointing at localhost. Now if I run this once again, because right now the base URL is set to the localhost and I'm getting pretty much exactly the same.